Hi everyone, welcome to the video on Introduction to Chemical Reactions. Real quickly, we're just going to review what a physical and a chemical change, what those are, and just look at what a chemical reaction is. What does it look like, and just talk about the basics. A physical change is when you alter the physical state of a substance, but you do not change its components. So if you look here, we have ice. It's still composed of water molecules. That's what we show here. Okay, and if you melt the ice, it's still water. Okay, it's the molecules look exactly the same. Okay, except for, of course, if they're in water, they're more randomly arranged and not as rigid as in a liquid state. Okay, but they're still the same. So physical states are just physical changes. If we wanted to convert the liquid to the solid, then of course we could freeze it. Okay, and the other vice versa as well. For a chemical change or a chemical reaction, you convert one substance into a totally different substance. And so here we have bonds that are breaking in our what we call reactants, or these are called starting materials, and we're forming new bonds in the product. So this is very important not only biologically, it's very important synthetically. Any pharmaceutical companies or anywhere, they're making new bonds. So they're breaking bonds and forming new ones, and this is what our focus is. So if you look here at hydrogen peroxide, okay, it's H2O2, so you have two hydrogens and two oxygens on it. If it decomposes, it becomes water. So here's water molecules in the background, and O2. Okay, and so these are totally different, okay, molecules here. Okay, and so this would be a chemical change. A chemical equation is going to use chemical formulas like we've been learning to write. We've learned to name and to write formulas, and some other symbols that we're going to look at as well, but where you have reactants, okay, are written on the left, okay, and you have products written on the right, okay, of your reaction arrow, okay, and so reactants are on the left and products on the right. Reactants are bonds are going to break. They're going to rearrange, atoms are going to rearrange to form different products on the right. So on the left are your reactants and products on the right. The numbers out front, these are called coefficients, and this is the number of molecules of that element or compound that react, okay, or that are being formed. Okay, these are going to be of importance to us. Okay, I want to go ahead and tell you that these numbers here, like H2O, okay, that's a subscript. Okay, we cannot change these numbers because if we change them, then you change the composition of the molecule. Okay, and so you'll need this later when you're balancing equations, but just remember that the coefficients out front tell you how many molecules you have of those, and we can actually change these, okay, so that our equations balance, and we'll do that at a later time. Okay, the law of conservation of mass states that atoms cannot be created nor destroyed in a chemical reaction. So that may seem a little unusual right now because I just told you that we break bonds and we form new ones. Okay, but no matter is lost, okay, and so if you look here at our coefficients out front, we use these to balance the equation, okay, and you're going to have the same number of atoms of each element on both sides of the equation. So this can almost think of this as an equal sign. Okay, of course you don't draw it that way in a chemical, you draw the arrow for the reaction, but what that's saying is, yes, we form different products, but we still have the same number of carbons on the left in this as we do on the right. We still have the same number of hydrogens on the left as we do on the right. Okay, so let's see this. So here we have just an understood one, so you don't have to draw that, but we have one carbon. Over here, understood one, we have one carbon. So our carbons are balanced. If you look at hydrogen, we have 4. Okay, 4 times 1, you multiply it times the coefficient. We have 4 hydrogen atoms. And over here we have 2 times 2. We have 4 hydrogen atoms. We have 2 times 2 oxygen atoms. And we have 2 oxygens here. Okay, remember, multiplies through by the subscript, and there's understood 1, so we have 2. But then we also have 2 here. 2 times 1 is 2. So we have 2 plus 2. So we have 4. And so this is a balanced equation. And you're going to learn how to balance these later. Okay, but this is the basics behind a chemical reaction. We have reactants, bonds break, new bonds form to form products. Okay, and we have the same number of atoms on each side of the equation. All right, our reaction arrow is written this way. Remember, it's different than we talked about resonance structures in a previous video. Okay, that's different. See how it's double-headed. A reaction arrow just has this single arrow, so that's what we've been looking at. If the reaction requires heat, you'll see this delta symbol. Oftentimes, out past the molecule or the element or compound that you're looking at, it will put in parenthesis S, which just means it's solid or liquid or gas, and then if it's an aqueous solution, meaning it's in water, it will put AQ in parenthesis. All right, next we will look at how to balance equations. So this is the end of our introduction. Thank you.